Good morning. Today we're going to learn about construction 9, how to construct an angle of a given number of degrees onto a given ray, which will be one arm of the angle. For this construction, you will need a protractor, a sharp pencil, and a straight edge. So this is something that the question might look like. Construct, and it uses mathematical notation to show the measure of, which we know are these two lines here. And then this symbol here means the angle BAC. So we're creating an angle that passes from the point B to A to C. And we know that that means that the angle must sit at the middle letter, the point A, and that needs to be a measure of 30 degrees. Given in the question then is the ray AB. Now we know that that is a ray because it has one end point and then the other end passes through point B. So it doesn't have two endpoints, just one. And that then shows that this will continue to go on forever in this direction. So we're going to be creating a 30-degree angle that sits at this letter A. Now with all constructions, we always start with a sketch. So here is my sketch. So we have the original ray, AB, and we know that we have to create a 30-degree angle so that we have the angle then BAC. When drawing my sketch, like as before, this is not accurate. This is just rough, so I haven't used my protractor. But what I have done is I've used my common sense and my understanding that 30 degrees is an acute angle and it's less than 45 degrees, which I know is half of a right angle. So it's going to look something a little bit like this, and this is going to help me then to guide me when I complete my actual construction. Okay, so let's get started. So as we know that the angle is going to sit at A, then this is the point that we must line up with the center mark of our protractor. So that is where the cross in the little window sits. We need to make sure it's really accurate, so the point is exactly where the two lines, the one vertical and horizontal, cross. We're also going to make sure that the baseline of our protractor is exactly on top of the ray AB. There we go. Once we're happy that that's lined up perfectly, and we'll keep it steady with our hand, make sure it doesn't slip, then we need to decide which of the scales that we're going to count up from. We're counting up from 0, as though along AB, our second arm of our angle, it's starting at 0 and it's going to raise up to what we want, which is 30 degrees. So that means we need to use the scale that starts at 0. So we're going to be counting up from the inner scale here. As you can see that the arm of our ray is passing through the 0 in the inside of this protractor. So using those numbers only, ignoring the outside ones, I'm going to find where my 30 is. And there it is. So without moving the protractor again, I'm going to put a little point exactly level with where the 30 is on my protractor, and then I can remove my protractor and I can connect then our point A, which is going to be the vertex of our angle, and I'm going to draw very accurately with my straight edge through that little mark that we created, making sure that the pencil line is exactly on the point A and goes exactly through this little mark. Again, like with all constructions, it's really important that your pencil is sharp, that you don't accidentally move your ruler. And as you can see, both my point A and the point I created, the pencil line is going exactly through them. The only thing left to do is for us to mark on the letter C, our additional point that we created, like I had put in my sketch, and then to actually notate the angle measurement inside the angle. So there we go, it's correctly labelled. Now, of course, it would be really useful then to verify, which we know means to check our answer, and we can do that by simply, again, putting on our protractor, lining up our centre mark and baseline, and checking that it does still measure 30 degrees, that we hadn't accidentally slipped with our protractor or our straight edge. And there we have it. Some people find it more useful to watch it being done by hand like they would, and others to see it being done interactively in the computer. So we'll have a look at it being done then on the computer screen. So there is our original. Now this time it's a line segment AB that has been drawn, and it's a 50-degree measurement that we've been asked to construct. Placing the protractor then so that the center mark here is exactly in line with the one end point, and the baseline of the protractor, which is the black line that's level with the lowest numbers, is exactly on top of the line segment, in this case AB. Now you can mark off the point where the required number of degrees is. So again, because the 0 is on the inside of the scale, now you may be asking, well, why are there numbers on the other side if we're not going to use them? Well, if we had put the protractor on the point B, so the angle we were asked to create was sitting at B, then it would actually be the other side of the protractor that the baseline went from the ray through to 0. So we would have to have used the outside scale. So it really is just depending on whether the angle is facing the left or the right. So we're just going to check, and again, using your sketch, it will help you to know which ones we're going to be calculating from. Remember that all degrees will start from 0, and it's like they're rising up. So this time we want 50 degrees. So where the exact line on the protractor is that says it's 50 degrees, so each one of these little lines is 1 additional degree. And we're going to put the dot then, which represents our new point C. We can then remove our protractor and line up points A and C with our straight edge and draw our pencil line through. Remember that those 2 points, the pencil has to go exactly through the 2 of them. And there you have it. In your notes copy now, could you please record the following? So well done everybody, you have managed to construct construction 9. And just want to say well done to all of you who sent in posters from your previous constructions. They will act as really good flashcards, revision cards, which you can use then before your junior cert or your summer exams. Just for fun, why is it sad that parallel lines have so much in common? Well, it's because they'll never ever meet. Thanks for listening. See you in tomorrow's class.